Hi. This is October 2018 question. Okay. So two projectile A and B are launched from position O at the same time. At time t, both projectiles have traveled a horizontal distance of OP as shown. Okay. So you can see they both traveled for the same time, started at the same time, traveled the same time. Both of them traveled same time. Okay, these are an important point. And they also traveled same horizontal distance. Okay, so both A and B, projectile A and B, travel the same horizontal distance. Remember, B has completed its journey but A did not. And by the way, this is not the maximum point, so therefore don't even try to do maximum velocity. Vertical velocity here is 0. Don't even try, because this is not the maximum point, because they did not mention us anywhere over here. Okay, so now what's happening is projectile A is launched projectile A is launched with a velocity of UA. Okay, so where the velocity of projectile A is UA, velocity of projectile B is UB. UB is making at an angle of 45 degree to the horizontal, and UA is making an angle theta with the horizontal, because they did not give us. Okay, now they said show that UA may be expressed in the form of this. Remember, the horizontal distance traveled by both the bodies are same, and they both travel for the same amount of time. Okay, so what is the equation for horizontal velocity, which we know of? The equation for horizontal velocity is the horizontal distance traveled is equals to horizontal velocity, okay, into the time. Therefore, you can even write it this way: u cos theta, because whenever something something is projected at an angle, it has two components: vertical horizontal component of the velocity, okay, which is the horizontal component of the velocity, which is mostly u cos theta, and vertical component of the velocity, which is u sine theta. Okay, u with that is going to be u sine theta. Okay, so, and this is the formula: u cos theta into t for horizontal distance. Horizontal distance, because it's traveling at constant velocity, no, therefore you have only sut. Half at square is 0. Why? Because acceleration in horizontal direction is assumed to be 0 if we ignore the air resistance. Okay, so let's find the horizontal velocity, horizontal component of velocity equals to, for this is for, let's say for A, it's going to be UA cos theta, because theta is not known to us. Okay, let's find horizontal component of velocity for, let's say, B. That is going to be UB cos 45 degree. Okay, so can we write both of them has traveled same distance, horizontal distance, right? So can we write horizontal distance for A is going to be UA cos theta into T, and horizontal distance for B is UB cos 45 degree. We know they both are equal to each other, SA equals to SB. So therefore UA cos theta into T is equal to UB cos 45 into T. So T and T gets cancelled, and you make UA the subject of the formula. If you make UA the subject of the formula, UA is equal to UB cos 45. Let's say how much is cos 45. Cos 45 is 0.707 divided by cos theta. So hence proved. Okay, so now we will show you the next question answers. Okay, they said explain for the paths of two projectiles to be shown, the speed of A should be greater than speed of B. They're saying that since A is covering more horizontal distance than B, why should A be more than B? That's what they're trying to say. Okay, the speed of A should be more than B, speed of A, because you can see that the A has not completed. A is continuously moving. A is continuously moving. Okay, so now okay, let me teach you something. When we were doing our sports this thing in school, we had this shot put competition. I don't know whether nowadays you guys have or not. You get this heavy ball and you have to throw it as far as possible. So we were studying those chapter, and our physics sir once said us, he was never able to explain us though why it is. I only understood from this question is that he's saying throw it at 45 degree. Okay, so we learned that, okay, if you throw anything at 45 degree, it will reach a maximum velocity. Sorry, it will reach a maximum horizontal distance. So basically the range. So remember, if you throw, let's say you were throwing something at 3 meter per second at this angle, let's say 10 degree. Okay, and if you want to throw it much more, so it will travel like this. If you want to throw it much more further with 20 degree or 25 degree, okay, same speed, 3 meter per second, you can even throw it much more further. If you want to throw it the furthest, if you want to increase the range at constant, see, speed is constant. If you want to throw the range, you have to make it maximum 45 degree. If you have to make it maximum 45 degree. Okay, so now it's saying, okay, I want to throw it even further than 45 degree, but I want to throw it at, let's 50 degree. If you cross that 45 degree angle, after that, even if you want to go 50 degree, okay, it's going to go maximum, but it is going to come down. I'm so sorry, that was my brother. Achha, okay, so now if you want to throw something even further, let's say you decided that basically you want more than 50 degree. Okay, so in that case your particle will go up, but it will travel less. So no, I want to go even further. Okay, in that case, when you cross your 50 degree, 45 degree, you need to throw it with, instead of 3 meter per second, throw it with, let's say 5 meter per second. Then it will go more distance, range. So let me show you the mark scheme for this answer. Okay, let me show you guys what is the mark scheme for this answer. See, in mark scheme, what's it written? The maximum range of a projectile is up to 45 degree. To have a greater range, if you want to go more, then after 45 degree, if you want to go more, a greater launch angle is required. Okay, at a greater launch angle, then the initial velocity must be greater. So your velocity should be greater if you want to go more than, if you want to go further, okay, further at angle more than 45 degree. I hope you guys understood. Now let's go to the next question. Next question is actually already solved. Okay, so let me redraw it again for you. So what's happening here is that, remember, the total time taken is t. B has covered the whole distance in time t, and it has covered half the distance in t by half. If full time t, it has covered half the distance in t by half. Okay, but before that, let me draw the velocity b. Okay, so velocity b will be something like this. It will have higher velocity and it will not touch 0 because it did not reach 0. That is the reason, because I told you that point is not maximum and velocity is not 0 there. So what I'm supposed to write here, I'm going to write UA sine theta. Okay, let me try for B, and remember the line of B should be parallel to A, because both of their acceleration due to gravity is same. So if I go there, so this is the graph I can think of. Okay, I tried to make it as parallel as possible, and it should be half also. Okay, okay, so it should look half. I'm labeling it this t by half over here, and it should be UB sine vertical component, right? Yeah, sine 45 degree. This is vertical component. That's why we are taking sine, not cos. Okay, because vertical velocity is not 0. That's why I'm doing this over here. Vertical velocity is 0 at half the time in B. That's why I did this graph. And both the lines are parallel because their acceleration due to gravity is minus g. Slope is negative. I hope you guys understood this question. Okay.